You are listening to Season 4 of Future Ecologies.
Okay, let's do it.
Okay, I'm Adam.
Mendel.
And this is Future Ecologies. And I'm here because Mendel invited me to be here to talk about natural climate solutions.
That's right.
Which are,
you know, a whole bunch of different things, but they're basically all ways that we can harness natural ecosystems or natural processes to mitigate the impacts of climate change.
Yeah, basically non-technological solutions to sucking greenhouse gases out of the atmosphere.
Right.
And this topic is all of the rage right now in climate circles because it's hopeful and it promises to provide a way for us to restore ecosystems and to protect biodiversity and have benefits for human communities as well, all while sequestering lots of carbon.
Yeah, natural climate solutions are usually pitched as this big win-win-win. And, you know, conveniently, that pitch usually skips the part where governments or industry have to reduce their own emissions.
Yeah, it's always easier to promote and invest in something that doesn't require the powerful to make sacrifices.
Yeah. Although, you know, ideally, those solutions are implemented in tandem with reductions in greenhouse gases from human sources. It can't be either or. It's definitely a yes and kind of situation.
Yeah. We have to do all of it. And even though we did a whole set of 7 episodes on the climate crisis a couple of years back.
Right, yeah. That's scales of change for newer listeners.
We actually didn't talk much at all about natural climate solutions in that series. Did we mention it?
No, I mean, it was supposed to be a series about climate inaction, you know, and of course we had to sneak some action in there too, but no, you're right. We really didn't cover natural climate solutions. So we're here today to redeem ourselves and maybe generate some hate mail.
Wait, really?
Yeah.
We don't want to do that.
No, I just think that this is honestly going to be one of the most controversial episodes we've ever made.
God, I hope not. I'm actually really jazzed about natural climate solutions, and I'm so excited that I did a bunch of background research. I hope that's okay.
You're incorrigible. You were supposed to be the blank slate for this one.
It's hard for me to pretend to be the blank slate on the subject that I spend most of my time working on.
That's fair.
Can I share with you what I found?
Sure.
Okay, here we go. Natural climate solutions tend to focus on enhancing the ability of natural processes to capture and store carbon in living biomass and in the soil.
Mm-hmm.
And also occasionally in rock, which we actually did talk a little bit about on Scales of Change. Anyway, we can sequester all this carbon by planting forests in places where they used to be or where they could be. That's afforestation or reforestation. We could also protect and restore wetland ecosystems, and especially peatlands, because they are so carbon rich.
Yeah.
And finally, we can improve agricultural practices to store more carbon in crop and pasture lands.
Hey, guess what?
What?
Today's episode is about that last one, storing more carbon in agricultural soils.
Nice. Okay. Well, in that case, one thing I learned about that is that there is huge potential for the agricultural approach, like globally, but also in Canada specifically. I read a major study recently that was published earlier this year and found that Canada currently stores about 20% of all global soil carbon.
Whoa, that's actually more than I expected. I mean, it is a huge country, but like a bunch of that is in wetlands, right?
Yeah, about a third of Canada's soil carbon is stored just in peatlands, which only cover about 12% of the land surface here, but, are a huge carbon sink. About half of that soil carbon is also in permafrost, permanently frozen soils, which, as we've learned, are a giant ticking climate time bomb.
Let's not go there.
Yeah, let's not go there. But the rest is stored in other ecosystems. And just to put all of this in perspective, the study that I read estimated that over 20 gigatons of carbon are stored in living biomass in Canada.
Right. So like trees and shrubs and roots and animals.
Yep.
And by 20 gigatons, you mean 20 billion metric tons of carbon.
Yeah, a gigaton is a billion tons, or about 10 to the 15th power of grams. A petagram, actually.
And that's a lot.
Yeah, one gigaton of carbon is a lot. 20 gigatons is inconceivable. But you want to know how much is stored in the soil?
Hit me.
Apparently, over 300 gigatons are stored in the top 1 meter of soil alone here in Canada. And as much as 260 more gigatons in the next meter down. So, 20 gigatons in all of the living biomass in Canada, and over 15 times that amount in the top 1 meter of soil alone.
Well, I have a statistic for you. The carbon that used to be in the soil and was lost due to agriculture over the past 200 plus years.
Oh, yeah. Lay it on me.
So this one is also an estimate, as are all huge numbers. But worldwide, agriculture has released over 116 gigatons from the soil.
Yeah. So there's lots of soil carbon in Canada.
Yeah, and lots of agricultural land in Canada.
And it would follow then that this country probably accounts for a big chunk of those global soil losses.
Yeah, I mean, the areas that have been farmed and grazed intensely in the past often have organic carbon levels that are way, way below their ancient capacity. And you can look all around the world. The places with the most intense history of cultivation are now the ones with the most degraded soils.
And the least soil carbon.
Yeah. So today, we're not just talking about keeping it in the ground. We're talking about putting it back. From Future Ecologies, this is Ground Truthing.
Broadcasting from the unceded, shared, and asserted territories of the Musqueam, Squamish, and Tsleil-Waututh, this is Future Ecologies, exploring the shape of our world through ecology, design, and sound.
Okay, so to sift through this story, I brought in some help.
Hello.
Scott, Adam, Scott Gillespie.
Hey, Scott. Thanks for joining us.
Yeah, I'm glad to be here.
So Scott is a professional agrologist in southern Alberta, which is the traditional and present-day home of the people of the Blackfoot Confederacy.
Yeah.
I have been to southern Alberta, but I don't think Future Ecologies has. Scott, would you help situate us?
Well, as our local country singer Cor Blund once put it, we're east of the Rockies and we're west of the rest, right at the edge of what we call the prairies in Canada, or the plains in the United States, the great grasslands of North America.
Well, for those of us who are even wester, maybe you could tell us what it's like to be out there.
Yeah, well, as you can probably picture, trees don't grow here naturally. It can be a place of intense winds and extreme temperatures. Historically, it would have been a pasture of huge herds of bison, and now it's been converted to mostly agriculture in one form or another. So in my area, which is in the south of the province, we live in what the farmers here call the brown soil region.
I love that. I love that you use the color of the soil to describe the character of the place that you live. What is it that makes the soils there brown?
It's basically the fact that it's so dry here. Over geological periods, we just don't get a lot of rain, so not a lot accumulates in the soil. As you go further north through the province, you get more rainfall, and then you get into what they call the dark brown soil, and then eventually you get to the black soils, which are these beautiful, rich soils that are full of organic material.
Do I detect a bit of soil envy there in your voice, Scott?
Maybe a bit.
So, Scott, maybe you should tell us what an agrologist is.
Okay, well, the easiest way to think of it is if you think of what a veterinarian does for animals, an agrologist does for plants and soils.
And you have your own podcast.
Yeah, plants dig soil.
where you help farmers practice something called regenerative agriculture.
That's right.
And, I think we'll get into exactly what that means later. But first, let's cover some basics. Climate change is here, and it's happening faster and stronger than almost anyone predicted. And as we all know, the main molecular malefactor is, of course,
Carbon dioxide.
Yeah, and ultimately, the carbon causing all these problems came from under our feet. The source of the carbon that we hear the most about, and for good reason, is fossil fuels. But it's not the only one. As you mentioned in the intro, a significant chunk of human-caused emissions came from the soil itself.
Right. Yeah. Living in the age of agriculture, we took what was it, Mendel? 116?
yes.
116 gigatons of carbon out of the soil. And that all went straight to the atmosphere.
Well, not quite, because it's not totally clear how much of the carbon went back into the ocean, either as dissolved carbon dioxide or, unfortunately, as dust from topsoil erosion.
Right. Yeah. Erosion and ocean acidification, neither of those are good either.
No. But, together we quantify those losses and call them the soil carbon debt, the carbon that we owe back to the soil. You could basically say that we cashed out millennia of carbon to grow our crops as quickly and easily as we could.
Yeah, and there is even a belief among the European colonists that with proper tillage, there is an inexhaustible supply of plant nutrients flowing up from the deep. Because of a fluke of the climate, they happen to be establishing these farms during a wet cycle, leading them to think that plowing fields caused more rainfall.
Wait, are you serious?
I'm serious.
Does plowing cause rainfall?
No, it doesn't. But it all ended when the dry cycle returned in the 1930s. So you might have heard of the Dust Bowl. The topsoil was so depleted, it just simply blew off the land.
So here we are, and we're looking back at all of the damage caused by intensive agriculture and all of the carbon that's been released. And of course, the obvious question is, why don't we just put it back, right? If there's room in the ground for billions more tons of carbon, then theoretically, we could solve climate change and repay our weary soils at the same time. It's the obvious fix.
And that, plus the little wrinkle of feeding the world,
Right, that, yeah, too.
that's the dream of regenerative agriculture. So regenerative agriculture means different things to different people, at least in terms of what it looks like in practice. But I think everyone would agree that the goal is growing food while simultaneously enriching and, that is, returning carbon to the soil.
Well, let's dig in. How does the carbon get into the soil, and how can we help?
Well, this is where things get more complicated than we could ever cover in a single episode. So let's just break it down to what we can understand at a couple different levels.
Sure. Yeah, that's par for the course for future ecologies.
The first level is that there's only one way to increase soil organic carbon: living, growing plants. So you could say plants dig soil.
You could.
If you think about it, ultimately, the only new carbon going into the soil is from the plants.
Right. Primary production, classic ecology here. As opposed to animals and fungi, plants famously photosynthesize, and they use the sun's energy to turn carbon dioxide in the air into their own bodies. A thing which, when I first learned it, absolutely blew my mind, because I thought they were building their bodies directly out of the soil. And it turns out almost all of that is from the atmosphere. Totally freaking incredible.
And it's important to remember that those bodies aren't just above ground where we can see them. Generally, about a third of the mass of a plant, which is almost all carbon, is in its roots. So grasslands put more into their roots, forests put more into the woody structures, but generally 30% is a good rule of thumb. So in a food system, there's a portion that is harvested and exported off the land. Some of that carbon will be eaten, and most of that will return to the atmosphere with every human breath.
But some of that harvest that you're talking about is not going to make it into people's bodies and onto their tables. because it's stuff like leaves and stems and husks and roots, stuff that we don't tend to eat as people, right? You have to grow a lot of plant material to get an ear of corn.
Right, and that carbon will get eaten by something else. The first step is usually for grazing animals, earthworms, or any other large critters of the soil to eat it. And they break it down to a more manageable size for the main decomposers, fungi and bacteria.
So you have the portion of the plant that we eat and respire, and you have the portion that, passes through our bodies, of course. But everything else should be going back to the field that it was grown on, right?
So in theory, yes, but practically no. Most food travels thousands of kilometers, sometimes across oceans. No one wants that back. If crop waste, food waste, or human manure gets buried in landfill, you'll get a lot of methane, a greenhouse gas that's 84 times worse than CO2. If instead it gets composted, you'll still lose some of the carbon to the air as those microbes eat and breathe, but you can put a lot of it back onto the field.
Yeah, the problem is still that you need to get it to a field. Maybe not the original field that it grew on, but any field nearby can benefit from this far better than just putting it into a landfill. But the real trick is getting that carbon to stay there.
Okay, then let's go to level 2.
Level 2.
The way that the carbon from these plants actually becomes part of the soil. As a plant grows, as much as 25% of the carbon formed by photosynthesis is released as a liquid by its roots. These liquids, called root exudates.
Yeah, because they're exuding. Roots exude exudates.
Yes. And these liquids feed the fungi and bacteria that live in the soil. Now, when I was in school 20 years ago, it was thought that the roots were just leaky. Now we know that they tune exactly what molecules they release. They are trying to attract the fungi and bacteria that they want hanging around their roots.
That's so wild.
Now, some of this liquid carbon will go right back off as CO2 as the microbes use it for energy. But through a complex series of symbioses, this microbial ecosystem locks in the carbon into clumps of solidified soil grains called aggregates.
Got it.
Now, how long that carbon stays in the soil depends on the stability of those aggregates, which may get disturbed by earthworms, new roots moving through the soil, tilling, droughts, or floods. Now, how much carbon gets into the soil depends on a huge number of factors. The amount of rain, the proportion of sand to clay, the slope, the health and the diversity of all those microbes. But the most important by far is simply the amount of photosynthesis happening in the first place. The more green, growing plants, the better.
Well, so far, none of this sounds particularly controversial to me.
No, I would say we're still on firm ground. That's all pretty settled if oversimplified soil science. But the debate really starts to heat up when you wade into the question of what should we do about it?
People arguing about climate policy? I can't believe it.
Well, this isn't the classic case of climate deniers versus the world.
No?
No. And, I wouldn't bother making this episode if it were. The people on both sides of this debate really just want the same thing, and that's carbon drawdown and food security. Where their opinions differ is whether we can count on soil carbon sequestration to get us there.
As in, should we pay farmers for adding carbon to their soils?
Oh, okay. So now we're talking, I think, about carbon credits, which are, market solutions for market problems. Am I right?
Yeah. Well, I'm actually still on the fence about it because farming at scale is really expensive and the margins can be razor thin. For a farmer, any little change in behavior can mean tens of thousands of dollars up front without any guarantee of success at the end of the season. So if we want to make our food system less destructive, we need to find a way to help farmers make the leap. But then again, if we're going to pay for that carbon, we better be damn sure it's real.
And that's the root of the debate. Selling carbon credits can lock farmers into complicated contracts that may or may not make financial sense to them. It might give polluters the excuse to continue their business as usual, canceling out the climate benefits. Or even worse, the soil carbon backing those credits might not be there at all.
Wait, what do you mean?
Scott, are you ready?
Yep.
Ring the bell, because we've got a list.
Did I miss something? Like, do we have a segment called Ring the Bell, Read a List?
Just go with it.
Okay, so there's 4 things that a good carbon credit has to represent. Additionality, non-reversal, lack of leakage, and permanence. Additionality means that we want the carbon to be sequestered because of the credit incentive. That is, it's additional to our baseline.
Right, the business as usual scenario. So for it to have any benefit to the climate, it has to go above and beyond the status quo.
Exactly. And then there's non-reversal, which means that those credits also have to contend with that temperamental flux that is soil carbon, either by a change in farming practices or, uncontrollable factors like a change in the climate.
Can you imagine?
Yeah, right? It could cause that carbon to go from being locked up in soil aggregates to right back up in the atmosphere.
Farmers aren't generally on the hook for reversals outside of their control, but it does raise questions about what happens down the line. In Canada and the United States, approximately 1/2 of farmers rent the land they farm on. They can't guarantee how the next tenant will treat the soil.
No. And landlords and owner-operators might also feel conflicted about signing contracts. What if an opportunity for a lucrative cash crop comes along, 5 or 10 years later, but the practices of farming it go against the sequestering of carbon?
Right, I'm starting to get a sense of how this could be complicated.
Well, then meet leakage. Leakage is when a climate positive action in one place causes a climate negative effect somewhere else.
Say, for instance, if, and this is a contentious if, regenerative farming practices result in lower food yields, then the market would put pressure on other farmers to convert yet more land, perhaps by clearing a productive forest or prairie.
Yeah, nobody wants leakage.
No.
Not only would that be outside of the carbon farmer's control, they might not even know about it, right? Like, you're talking about a systemic pressure because of the price of food or land.
Yep, you've got it. And finally, there's permanence.
So permanence is kind of related to reversal, but it's about the time horizon. We've been talking about how carbon naturally cycles through plants, the soil, the air. But if our concern is reducing greenhouse gases, we really want that carbon locked away for as long as possible, ideally on geological timescales, like the fossil fuels it mostly came from. In the world of carbon credits, the target is usually set, somewhat arbitrarily, at 100 years.
And outside of places like bogs,
We love a bog.
it's just really hard to know where that carbon will be in a century. Think about the land around you and what it looked like 100 years ago. I'd bet it's quite a bit different than what it looks like today.
Yeah, so that's a lot that any legitimate soil carbon credit would have to account for.
Yeah, no kidding.
So how do we actually do that? Like, how do you prove that any of that is working? That you have, let me see, hold on, additional carbon that is not reversing itself back into the atmosphere and isn't leaking out somewhere because it's permanent.
We'll get to that after the break. Hey, me again. Here to tell you that this episode is sponsored by you. You make Future Ecologies possible by sharing it with the people that need to hear it and encouraging them to support it on Patreon. So far this season, we've had the help of 3 guest producers and 20 musicians, not even including Adam and myself. I'm so proud that we can pay all of those people for their work, and we can do so because of our supporters on Patreon. Plus, I can usually make rent and get groceries. If you like this show, it's because we spend an incredible amount of time and effort on every episode. At least months, sometimes years. You don't get to hear all the drafts and revisions that go into each one, and hopefully you don't even notice that they're there. We just want you to come with us on a journey into an idea, and to let sound help tell the story, not get in the way. And so I wanted to remind you that it's just us. No parent company, no corporate sponsors, no one to answer to, except for you, our audience. We are a proudly independent podcast, and every single supporter makes a huge difference. Help us make this show so that the world can hear it, and get early episode releases, an exclusive podcast feed for bonus content, stickers, patches, and access to one of the most delightful Discord servers out there. Support the show for as little as $1 each month, and join our community at futureecologies.net/patrons. We really appreciate it. Okay, I'm Mendel. That's Adam.
Hey.
We're joined by Scott.
Hello.
And today on Future Ecologies, we're talking about the promise of soil carbon sequestration, or how we could use food-producing land to fight climate change.
Well, I wouldn't say the promise, but rather the possibility. And in practice, that might be a whole lot different from the feasibility.
Right. I mean, basically, I came here super stoked to talk about natural climate solutions, and you guys are just raining on my parade.
Yes.
So to recap, we know in theory that the soil could hold as much carbon, at least as we've taken out of it since the agricultural revolution, which was how much again?
116 gigatons.
Yeah, that's a lot. But because that carbon doesn't like to sit still, it likes to flow through plants and microbes and then back up into the air. And it might even leak out somewhere else because of pressures on land use. Actually keeping it in the ground is a lot easier said than done.
Exactly. But that's not to say we can't do it. Regenerative ag, as it's practiced today, is really just a repackaging of different traditional agricultural techniques from all around the world. Cover cropping, composting, no-till or low-till, biochar, agroforestry, matrix planting, silvopasture. None of these are new ideas, and they're all known to build soil and turn it dark and rich, basically packed with organic carbon.
That's true, but proving it and selling it by the ton, that's another story. And it brings us into the realm of MRV.
We love a good acronym. What is MRV?
Measurement, reporting, and verification. Basically, accounting and auditing in the world of carbon sequestration.
Please tell me this didn't turn into an episode about accounting.
How about we just focus on that one key aspect, measurement. To know how much carbon any intervention helped add to the soil, first you have to measure how much carbon is there already.
Sure, yeah.
And that's not easy or cheap.
Because soil carbon's not a simple compound to measure, like say CO2. Organic chemistry is an entire scientific discipline studying all the compounds that carbon can make.
Can I just say that was the best summary of organic chemistry that I've ever heard, even after studying it for a couple years.
Well, thanks. So because carbon can take all those different forms, and because soil is really variable and heterogeneous, on a landscape scale, carbon can be incredibly patchy. So you need to sample enough points to get good data. Sample too few, and you might be getting the wrong picture. Sample too many, and you're just wasting time and money.
And by sample, we mean physically going into the field and getting a soil core. That is like drilling out a tube of dirt and then shipping it off to a lab to be analyzed. Every single core is at least a few minutes of work.
Provided you don't hit a rock.
Yeah, plus all the logistics and expenses around the lab analysis.
I mean, I've done soil sampling before, and it's not that hard. But I've also only done it on like small areas of land.
Well, consider that the Canadian prairies alone have 77 million acres of farmland. Most city blocks are just a few acres in size.
Yeah, it really all adds up.
Well, that's not great. Is that really the best option that we have?
There are a few promising new technologies, but right now, none of them are ready for prime time. Some folks are aiming to use satellites, so-called remote sensing, to measure soil carbon en masse. Some are using these meteorological stations that are called eddy towers to calculate the carbon flux at this landscape level. And then there's others who are developing tools that can measure the carbon right there in the field, instead of a soil core using a probe that basically detects the color of the dirt.
Right, like brown, dark brown, and black.
Exactly. Color can be a decent proxy for the amount of organic carbon in the soil. And all of these tools will be used to improve computational models so that we can better predict what's happening to the carbon and then use the magic of statistics so we don't need to take as many physical samples.
Yeah, real magic. They've got incantations like regionalized variables and conditioned Latin hypercube sample design.
That's real arcana. It's almost like you want to explain a thing.
I don't.
Okay, so you're saying that these techniques are good enough for the kinds of large estimates we've been throwing around in this episode so far, but not necessarily good enough to be sure that we are selling a certain amount of carbon when we're making carbon credits.
No. And there might be one more problem.
And it's a big one. So, the way soil carbon is measured now, those samples are usually taken from the top 30 centimeters.
That's 1 foot for those of you who think like me.
And, that's because the deeper you go, the more expensive and challenging it gets. Try pushing a probe into the soil. Like you said, Adam, the top is kind of easy. But the deeper you go, the more pressure it takes, almost exponentially.
I've done a lot of soil sampling over the years, and I can definitely attest to that. Soil sampling is typically done with hydraulic probes mounted to pickup trucks, and the force is enough to lift the truck, or bend the probe if you're not careful.
Wow, okay. But why go deeper? Isn't the top foot of the soil where most of the roots and microbes are anyway?
That's mostly true, but some roots go 2 or 3 times that deep. In the case of prairie grasses, 10 times or more. And of course, in other places, the subsoils can and will be a completely different situation.
And there's a growing body of evidence that when we only measure carbon sequestration in the topsoil, we're only getting a little slice of the whole picture.
Right. Those estimates that we covered at the beginning of the episode were all about how the deep soils are a big part of the carbon stocks for Canada.
But those were just estimates, not field-by-field measurements. What Mendel is talking about is a particular study that looked at how soil organic carbon accumulated with and without cover cropping, and a variety of inputs like chemical fertilizers and compost. What was important about this study is that it was long-term. Most studies only last the length of a grad student's degree, which is about 2 to 4 years.
Not exactly the timescale of soil formation. That would be a PhD.
No, but we can do a little better. In this study, soil samples had been taken over 19 years, and various combinations of cover crops, irrigation, synthetic fertilization, and compost were kept consistent over that time. Unlike your typical 30-centimeter cores, these ones went 2 meters down, with 5 sample points over that depth.
That's hardcore? Deep core? Anyway, deep cores, long duration, different field variables. I'm with you.
So when no inputs were added to the system and no cover crops were planted, carbon in the topsoils decreased. Exporting food off the land meant that the microbes needed to break apart the savings of long-term carbon for nutrients.
As you'd expect.
Now you remember how we talked about that to build organic matter, we need more plants growing.
Mm-hmm.
Cover crops are a way to achieve this in a farming system by growing something in the shoulder season, before and after the cash crop. It's one of the key practices in regenerative systems because it helps to build the soil.
Right, yeah, I do this in my garden too.
Yeah, so when winter cover crops were added to the conventional system, as in a system that uses synthetic fertilizers and pesticides, in this particular study, the topsoil saw a statistically significant increase in soil organic carbon.
So far, so good.
But the rest of the soil down 2 meters had a statistically significant decrease in carbon. When looking across the whole profile, they saw not only less sequestration, but net positive emissions on the fields with cover crops.
Wait, what?
Scary, right? That means what we typically perceive as carbon sequestration might actually just be carbon concentration in the top layer of the soil. And because of how much more massive the subsoil is, there may still be significant net carbon losses overall.
So what you're saying is that when we're just measuring the first foot or so of the soil, we might fool ourselves into thinking that we're sequestering carbon, when in reality, it could be the exact opposite.
You got it. But just to be clear, having this carbon concentrated near the surface isn't bad. That particular crop system was doing this naturally, and so there's probably a reason why it wants the carbon there. After all, that's where most of the roots are, that's where the moisture is, and that's where the microbes live. So it's good for the farmer, just not so good if you think you're sequestering carbon.
What about adding compost? Did the study consider what happens if you're adding compost to the fields?
In that case, the carbon did increase overall. But zooming out, that's essentially the result of leakage from somewhere else. If that compost didn't go back to the field that produced it, you've just transferred carbon from one area to the other.
Basically more like carbon import rather than carbon sequestration.
Yeah, that's a pretty sobering study. Thank you for, hitting me with it 3/4 of the way through this episode. So I guess, what that makes me think is that when we're talking about, trying to sell that carbon or allowing it to be used as an offset for big industrial emitters, there's a real risk here that that's a wasted investment, or it could actually actively make things worse.
Yeah. What it really means is that we still have so much left to learn about the dynamics of deep soil, and then we need to factor that into our models. And so this is really where the problem lies. There's a lot of hype because of models that show big changes, but you dig a little deeper and you see that most of them only go down 30 centimeters and sometimes less. As of right now, they can't say what happened in the subsoil. They can only say what happened near the surface.
Yeah, and maybe eventually we'll develop an understanding of how to lock huge climate-shifting amounts of carbon down into those deep soils and farm them at the same time, and do it on a timescale that is much faster than how long it took for those soils to form. But for now, we really can't count on it.
Well, thanks, you two, for a hopeful and uplifting episode. There's nothing I love more than pouring cold water on a natural climate solution. That's what I'm here for.
Yeah, I would say it's our pleasure, but,
So, I guess to ask, the obvious question, what now? We're, as a society, are kind of banking on the soil being a part of our climate solution, and especially agricultural lands. Does this mean that we just give up on that dream? Do we give up on regenerative agriculture?
No. No, I don't think we should. Regenerative ag can do a whole world of good, especially now, especially during climate disruption. But, in order to realize that, I think we have to expand our focus, right? Out from just carbon and from carbon markets.
Yeah. If all we care about is carbon, we're going to miss the forest for the trees.
It's funny you saying that coming from a place with no trees at all.
Okay. Then how about missing the prairie for the grasses?
Or the roots for the exudates.
That's acceptable.
Anyhow, one thing is indisputable. Regenerative farming is still a good thing. All those regenerative practices can make a soil system more resilient to climate extremes, helping water filter in slowly to manage big rains, holding onto it longer to last through droughts, and just generally increasing resistance to pests and erosion. What farmer wouldn't want that?
I mean, I want that. I want that on my land. And there's a bunch of other natural climate solutions for agricultural lands that I think do have a more guaranteed delivery in terms of carbon sequestration. I'm talking about planting more trees on agricultural lands as riparian buffers or as hedgerows or as silvopasture or agroforestry, right? Getting that woody biomass in there, that's going to do a world of good in some places. In other places, just doing leguminous cover crops to help reduce the amount of nitrogen fertilizer that's applied to the land is a huge benefit, because a bunch of the nitrogen fertilizer that people apply ends up in the atmosphere as nitrous oxide, which is a greenhouse gas that's 300 times as potent as carbon dioxide. So there is a whole suite of practices that are still beneficial for the soil and for the farmer and for the climate.
Yeah, I think all of these things add up to huge benefits in water quality and ecosystem health in general. And, hopefully still food production. And, practically speaking, some of those regenerative practices might feel more within reach, like winter cover cropping or reducing tillage to the minimum. Others would mean a pretty complete reimagining of how we plant and harvest at scale and what those fields look like what you just described. But with agricultural systems and practices so deeply ingrained, I really think that farmers need help to try something new.
And the podcasters of the world are here to provide it.
Yeah, podcasters and governments and people who eat food, right?
Yeah, I am a podcaster. I'm not a government, but I am a person who eats food. I think we are all people who eat.
Mm-hmm.
And so we all play some part in our food systems. One thing I have learned farming is that every farm is different. And so I guess the regenerative practices that are going to make sense in one place will be different depending on the farm. What do you think the farmers in your area need, Scott, in order to be able to embrace regenerative practices? What are you seeing?
To me, I think the most critical thing is that there has to be some type of economic reason to do it.
Like a carbon credit?
Well, I had hopes in the carbon credit until I did so much research on this that it doesn't look like that's going to be a viable solution.
So it needs to be something else.
Even just incentives to start to get over that initial hump in adoption would be a critical thing. Realistically, it's going to have to be something that's going to make economic sense to the farm. And as an example, in the United States, where cover crops have really taken off, is where they had weeds that were resistant to their herbicides and their costs were just getting out of control. When they were able to integrate the cover crops in, they were able to bring their costs down. So whether you're farming at a small scale, like a market garden, or up to thousands and thousands of acres, it comes down to economics.
Yeah. And that's something that doesn't have to come from the potentially greenwashing and, supposedly outcome-based world of carbon offsets.
Yeah, there's things like crop insurance, low interest loan programs, or just straight up cash incentives for regenerative practices that can help farmers close the gap between doing good for their soil, making a living, and putting food on all our tables. And I'm happy to say there's all sorts of these programs starting to, crop up.
You made a pun, Scott. That's delightful. That's usually my job here. What kinds of regenerative practices are you seeing being implemented in the prairies where you live?
Well, the huge shift over the last quite a few decades has been going to no-till or at least minimum tillage. So plowing is very rare in the prairies and very similar to cover crops. It is showing similar patterns of carbon concentration in that we do get more carbon in the upper levels, but not as much in the deeper levels. However, just because that happens doesn't mean that it's not a good practice for the farmer. They're seeing a lot of benefits from it.
Yeah. So some incentivization is important. Like stepping back from this question about carbon credits, what occurs to me is that this whole question of how much carbon is being sequestered and how do we measure that and how permanent is that, it is a lot of complexity and noise that we've kind of like shoved into what could otherwise be a very simple conversation, which is that we know that as a society, we are emitting too much carbon. We should be making the people that are emitting all that carbon pay, and then we should be taking that money and incentivizing the practices that we want to see on farms and elsewhere. And we don't necessarily have to quantify that as stringently as we are if we're not counting on the slimmest of margins for climate recovery, if we aren't trying to, finely balance the amount that we're emitting versus the amount that we're sequestering, right? If the general idea is emit less, sequester more, then we need to reduce emission, which we definitely know how to do that, and then incentivize practices that we know will eventually sequester carbon, even if we don't know exactly how much or over what kind of time span that's going to happen. Do you know what I mean?
Yeah, you're saying not on a gram by gram or ton by ton basis, but just to tax polluters and use that to subsidize regenerative agriculture or agriculture in general.
Yeah, I mean, farming is already heavily subsidized. It's a question of shifting those subsidies to actually support the kinds of practices that we want to see as a society, I think.
Totally. And, while we do that, I think we just need to get comfortable with the fact that we're still learning. We're learning that there's a lot more left to learn about soil, especially.
Yeah.
We know now that plowing doesn't make it rain, that soil nutrients don't just spontaneously appear, and that plants build their bodies from the air and not the ground.
Yeah.
But despite how far we've come, we're really still just at the beginning of a soil science revolution, and we're overturning notions that have been in place for decades. You could say some recalcitrant ideas. At some level, we know it's possible to put a lot of carbon back in the soil because it was there once. But now we also know that there's a lot of work to be done before soil carbon can be the silver bullet we'd been hoping for. But that doesn't mean we just wait around in the meantime. We already have the tools we need to change how we farm and how we eat, to rebuild the soil in the places where it's the most degraded, and to do whatever we can to regrow a livable planet.
Okay, so if I understand you two correctly, the regenerative practices that we've been discussing this whole episode are good for the soil, they're good for farmers, and they're very likely good for the climate, at least in the long term. But we don't yet have the deep understanding of soil processes required for us to confidently predict and quantify those benefits, at least enough to think that we can start selling them to each other or to people who are going to use them as an excuse to pollute, maybe. Is that right?
Yeah, that's about it.
And to close things out, I just wanted to paraphrase a paper on overcoming the barriers to adoption of cover cropping, since I think it also applies to all sorts of regenerative practices. It's easy for individual farmers to feel powerless to do what they think is right, but the decisions of farmers are a form of embedded agency. One farmer alone may not be able to do much, but just by doing it, they will help another farmer to see a different way. Farm by farm, field by field, those decisions aggregate, like grains of soil, into watershed-scale effects.
Future Ecologies is an independent production. In this episode, you heard Scott Gillespie, Adam Huggins, and myself, Mendel Skolsky.
But we had lots and lots of help on the background. From Kimberly Cornish, Nicole Tachis, Stephen Schaefer, Emily Oldfield, and Sean Smuckler. Thanks.
Mix and sound design was by me, with music by Patricia Wolf, Eric Tuttle, Thumbug, and Sunfish, Moon, Light.
A full list of credits and citations can be found at futureecologies.net,
where you'll also find the rest of our episodes and a way to get in touch. We always love hearing from you.
Even if it's hate mail?
I guess we'll find out. Thanks as ever to all of our supporting listeners on Patreon. This show simply wouldn't be possible without you. To be a part of our incredible community, head to futureecologies.net/patrons.
Thanks to the Sitka Foundation for helping to support our 4th season. And to everybody else, if you can't help the show out with your money, you can still definitely help out with your words. Share your favorite episode with somebody you love, or just the next person that you meet, who you might also find that you eventually love. We really appreciate it.
Is that it?
That's it. Thanks for listening.